Okay, so yeah, as JC said, I'm Kelsey Brock. I'm the Early Detection Botanist for KISC, and I've got Bill Lucy, the KISC project manager hiding off screen, so he's here too. And today I've been asked to present about how we prioritize plants for eradication. So how do we weigh the potential invasive impacts against feasibility to decide which ones to prioritize first? Not going. Oh, there it goes. Okay, so when I took this job 2 years ago, I knew I was in charge of detection and helping prioritize invasive plants. So I've got here on the screen a figure from the KISC strategic plan, and basically I was hired to help fill in the box behind the great question mark. And so you can see that this process starts to inform really a lot of what we do here at KISC. So it helps inform which species we take on as target species, so which species we commit our resources to until eradication. It's supposed to help us decide which species we know are already have such high potential impacts that we would rapidly respond to them immediately, and which species maybe are too far gone to be target species, but maybe they could be partners of species. And then finally, which species, if we succeed, we can consider eradicated, and which species, if we fail, we have to consider retiring. So you guys have probably seen this invasion curve before, but it's important to bring up again and again, because it answers the question, so why do we prioritize? Why not just kill weeds? So here's the invasion curve where we've got abundance of an invasive species on the y-axis and time on the x-axis, and you can see that there's this nice lag time usually where the abundance doesn't grow too much until it gets to a certain point. And then as it increases, we get eradication of that species is increasingly unlikely. So KISC likes to operate in this red box here, where we commit our resources to eradicating species. So that means we have to make really good choices about which ones we choose to eradicate. So, so that brings up the question, why not just kill the new weeds then? Is that so hard to just kill the new ones? And so me and my husband both work in early detection, so we have a lot of nerdy conversations at home a lot of the time, and he's a really great cartoon artist, so he helped me envision this scene. This is what we wish early detection was.
Do that?
Where, where we know exactly what the enemy looks like, and we know it's coming, and we have our early detection person, they've got the binoculars trained, and then we've got the rapid response person, and it's just a matter of saying, as soon as that invasive species touches land, you say fire, and it's gone. Early detection and rapid response. But unfortunately, the things are a little bit more complicated in Hawaii to use that model. So what it's actually like is you have to ask yourself a question, what is a new weed? What is early detection, basically? Well, a human's version of what early is a little bit different than what a plant's version of early is. So in a paper that Kurt Daler wrote in 2009, he looked at some of our dominant woody invaders in Hawaii, and we saw that we had lag times up to 20 years, or 22 years, sorry, or 14 years on average. And then other studies that look at just general, like all species of alien plants, have shown that lag time can be up to 65 years. So we have a little bit of a window sometimes. I mean, obviously, sometimes we get species that come here and they start invading right away, but sometimes not. And since our attitudes about invasive species didn't really start gearing up until the 90s, it's kind of a blessing in some ways. We have a little bit of a time lag window that we can take advantage of.
Mute on.
Secondly, it's complicated mostly because there are a lot of alien plants here already. So Hawaii's alien flora, as we currently know it, Here's a table of some total vegetated area and total number of taxa. With the vegetated area, there's a lot. So this is Hawaii native in number of vegetative acres, and this is all of Hawaii invasive, which it's either alien dominated or it's an alien native mix. So it could be some proportion of alien. And then over here we have Kauai native and Kauai invasive. And you can see that a lot of, these are pretty coarse numbers, but a lot of our land mass has alien species on it. And then that's pronounced even in our biodiversity, where half of our flora is alien. So in Hawaii, we've got a number about 1402. For Hawaii naturalized alien, 1442. And then for Kauai native, we've got 688. And these are including varieties and subspecies as well. And Kauai naturalized alien, about 690. I want to point out that these numbers are very approximate. The point to take home is that they're roughly half and half. We don't have a really good way of tracking which species become naturalized, which ones have become invasive, and I feel like we could do better at that, and that we should do better at that, so we can figure out so we can keep track of things that's happening as far as alien plants concerned. And this doesn't include things that have not naturalized, so it might just be potted in someone's yard. So if you were to employ that very over-idealistic strategy in Hawaii today, you would have some troubles because, sometimes it's not always easy to figure out what's going to be invasive. However, the Hawaii Pacific Weed Risk Assessment, thank God for that, that really helps. And but sometimes it's hard to figure out, once it is here, how bad are the impacts going to be. So, and then we have lots of stuff that's here already, but thanks for that lag time, we might have things that are in their eradicable stage still, and we just have to figure out which ones they are. So we need our early detection and rapid responders to be looking both ways, both at things that are really new according to human standards and things that are new according to plant standards. And we want a way to be able to prioritize them. So we want to be able to say, okay, well, that's first priority based on invasive impacts and feasibility. And okay, we'll say that one is low-hanging fruit, so that's our second priority. And that should be our third priority. And we want to be able to say, okay, that one is infeasible. That one's too far gone. We shouldn't waste our money on that. And we want a way to say, okay, that one's non-invasive. So my job was to help fill in the system behind this gray box. So how to detect and prioritize and how to plan and gather data to do that. And so basically this was all about gathering data to make good decisions. So today I've been invited to talk about the very last step of this system, how we prioritize the plants that we decide to take on as target species. But you should be aware that there's a whole upstream set of decisions and gathering of data that feeds into this process. And that includes just kind of getting a pulse on what kind of plants we have here on the island, a botanical survey list. When I do my early detection surveys, what do I look for? And then based on that, which ones seem like they're not too widespread that we can consider to prioritize as target species. So basically, this whole process utilizes 3 different types of data that I think are crucial to making decisions about prioritizing plants. Because basically what we're trying to do is minimize uncertainty. We want to minimize the uncertainty and try to do our best and allocate our resources in the most efficient way possible. So in order to do this, we need taxonomic data, ecological data, and geospatial data. And if you're missing one of these 3 nodes, then you're going to have an increased risk that you're allocating your resources improperly. So for example, if you have taxonomic data and ecological data, but not geospatial data, you run the risk of targeting non-eradicable species because you don't have enough data about its distribution. if you have taxonomic data and geospatial data, but not the proper ecological data, then you run the risk of targeting species with little invasive impacts because you don't have those life history traits or evidence of what it does outside of its native range elsewhere in the world. And then if you have only ecological data and geospatial data, but not taxonomic data, then you run the risk of targeting the wrong species. And you could do this either by misidentifying it, so all of the geospatial and ecological data in the world is not worth anything if you don't have it matched to the right species identification. Or if you have incomplete species inventories, you could be targeting the wrong species just because you're missing something. So when figuring out that, okay, we have to develop a plan to prioritize these species, the first thing I did was do a literature search. And I found that there weren't any models that were actually directly transferable to KISC. I did mention now that this OHISC did an excellent job of doing something similar in this prioritization process. So they put a lot of thinking into it and did a lot of work. And so I'm basically kind of just taking that thought process where they left off and then including additional resources and looking at different literature that has been published since they made theirs. And so when I did my literature search, I found that there wasn't much of a focus on feasibility. So it was either not included or it was assessed from like a country scale, multiple agency perspective. And so because it was so broad scale, it didn't have the specificity of a single agency so you could really determine whether something was feasible or not. And we know that feasibility is really important. If we want to eradicate things, you know, oftentimes it's not just about weighing how bad the plant is going to be as far as invasive impacts goes. It's about figuring out whether we can actually win. And then during my literature search, I found that people have different ideas about what eradication is, and this is mostly to do because most places aren't islands. And so, you know, on a continent, they're going to be concerned about prioritizing populations for eradication. But we're an island. We can take advantage of the ocean as a barrier and go for species eradication. So I definitely wanted to work that in. And then in the more recent literature, there was a complexity issue. So some of the models use a differential weighting criteria. So say you said, okay, form thickets and disperses by birds, for instance, is a criteria that you wanted to use to determine if it was invasive. You would use this analytical hierarchy process to weight them differently. And that was really cool. You know, those are really cool papers. Right now, the one I've read has been the one in Whippet from California, and there's also one in place in South Africa. But they do have a reliance on complete spatial data for GIS analysis, and because of the complexity, I couldn't find a way to shift those models right over to Kauai without making that my full-time job for several years. And they're often very heavy on computing as well and programming. So basically, we came up with a process to prioritize plants. And I'm not saying that it's the magic bullet for all organizations, and it probably will be revised and we'll get feedback over the next couple of years. But it definitely is an indication that something is needed. We need some sort of process in place to sort through all this complexity of alien plant diversity. So that's what we'll be talking about today, is how we prioritize plants. And just so you know, this is actually a very active area of research. So when I did my literature search, many articles are just published within the last couple of years. So what we should do is just keep communicating with other scientists elsewhere in the world and get feedback from each other and see what we can learn from each other as we vet these processes over time. Okay, so the prioritization process is a 5-step process. And when I do this, I do it with the intention that I'm going to write it into a report, and then I'm going to show it to our committee so we can make better decisions. So the first step is to go over the detection and distribution of your particular species. So this is where your field data comes in. So how many sites did you find? How many individuals are there? How many acres? What was the density? Was it sparse or was it a thicket? Were they mature or immature? Were they cultivated plants? And then this is where you'd also mention, when was the first plant detected on Kauai? And this is also where you would do a herbarium search. So Kauai is lucky enough to have a herbarium on island at the National Tropical Botanical Garden, and they actually have a active collection program. So they have been collecting lots of plants even in recent years, and they're very good botanist staff there. And when good botanists are on the island and they see something new, they oftentimes collect it and put it in a herbarium. And so they're super useful tools for early detection. And a lot of the herbaria, so I think Bishop has most of their Hawaiian Island stuff digitized, and National Tropical Botanical Garden is majority digitized as well. So sometimes looking for this data is just as easy as searching a database. So there's not really any excuse why you shouldn't look there to see if you can find additional locations of your plants. And also, this is where we would map our points out and see if the distribution patterns hint at a dispersal method, like gravity or bird dispersal, or if it's dispersing along waterways or something like that. Sometimes you can't really tell, but it could be helpful down the road. And step 2 is where we consider the Hawaii Pacific Weed Risk Assessment, which some of you, or most of you, have probably heard of. And this is an assessment that's designed to predict which plants, when they come to Hawaii, are going to be invasive. So it's comprised of 49 questions, and from these 49 questions, you get a numerical score and a rank of low risk, high risk, or evaluated, which is basically insufficient information. And so in my report, I read the weed risk assessment, I review it, and then I list the criteria that contribute to a high risk score, because that will be very important to inform subsequent steps. It's full of really great resources in the weed risk assessment, so it's good to look into those. And then this is also kind of the first filter. If the plant is a low risk evaluation, then something's wrong. Either it's not going to be very invasive and it's not really worth your time, or maybe you know something about this plant that couldn't be collected from the literature review when they did the weed risk assessment. All right, so now we go on to step 3. And this is where we assess the potential invasive impacts. And so we do this in 3 different ways. So we assess the impacts on natural community structure or composition. We assess the impacts to agriculture, culture, and human systems, and then assess the impacts to biotic and abiotic processes. So this is where I get a lot of questions. Why don't you just use the Hawaii Pacific Weed Risk Assessment to determine invasive impacts? Why are you adding more criteria? And so here on the left-hand side, we have the paper that vetted the Australian weed risk assessment and adapted it for Hawaii by Kurt Daler et al. So this is the paper where the WRA was tested. And then he's got this figure, or they've got this figure here where they took a bunch of plants and they had experts score from across the Pacific, whether it was a major weed, which is up here in the 2 category, or maybe not a weed at all. And then they averaged them. And then on the x-axis, they had the weed risk assessment score. So, not a pest in this zone, and then is a pest over here. And as you can see, there is a pretty good correlation. So, and especially if you're used to looking at this for ecology, like this is a pretty cool regression. So why not use a Hawaii Pacific Weed Risk Assessment to prioritize plants? And there are two reasons. The WRA is composed of 49 questions. And the first is there is a statistically significant relationship between the risk, the score, and the number of questions answered, which might not actually indicate that it is worse. It just might mean that there's more data out there. But that's actually a really weak relationship, so that one doesn't really bother me too much. The one that that is the major reason why we don't use just the WRA alone to prioritize plants is because there's a very subtle but important difference between predicting the likelihood that a plant will invade, which was what this whole paper was totally about. Anything we do beyond this is a kind of extrapolation of that idea, of that concept. So there's a subtle difference between predicting the likelihood that a plant will invade and predicting how bad the invasive impact will be. And so of those 49 questions that compose the WRA, 2/3 of them are likelihood-based, so how likely is it going to be that it's going to invade, and 14 or 16 questions are consequences-based. And this is really what we want to ask. We want to see, okay, what are the consequences of letting this thing go going to be? So here, if I was a KISC manager and I was trying to decide which species to prioritize, I would pick these ones. Say we want 5 species and these ones have the highest weed risk assessment score, so I pick this one. But then there's a problem where this one here, most experts don't even really agree that that's even a weed, or even it's either a minor weed or it's not a weed. And then if you ask solely experts, they would probably pick these ones. So between asking experts and just using the weed risk assessment score, there's only an overlap of 2 species. And I mean, there's going to be a lot of subjectivity with asking experts, but basically we need to be more accurate than that. We don't have enough resources to be able to make, to allocate to species that aren't really going to be that high risk, or not going to have that much invasive impact, rather, sorry. Okay, so now we're back to step 3. So now we're assessing the potential impact. And so basically each one of these things we went over earlier gets a score. So a score of 0 means no perceived impact, 1 is minor impact, 2 is moderate impact, and 3 is major impact. So for the natural community structure, something that's no perceived impact would be something like it establishes kind of sparsely in an existing vegetation layers without really affecting adjacent native plants. And then something with major impact would be something like it majorly excludes or totally excludes all other layers or species, kind of like we would see in Myconia in Tahiti. And then for the agriculture, culture, and human systems, you might give something a no perceived impact if it's like an occasional weed where maybe a farmer would not even notice or care to apply any control effort. And then something that causes major impact would be something that causes major yield loss. It could be toxic or injurious to livestock. It requires major effort ongoing to control. And to assess the potential impacts to biotic and abiotic processes, something that has no perceived impact would be something like no effects on soil moisture or nutrients. It doesn't affect native animal habitat use. And then something with a major impact would be, it majorly affects hydrological cycling. Stream flow is down 75% or something like that. Or it causes trophic cascades, where it affects trophic levels like in animals or grazers beyond that. And so from there, you get a potential impact score. So all you do is add up the score from A, B, and C, and you'll get a score from either 0 to 9, with 0 being no impact and 9 being the most potential impact. Okay, and so now we go on to step 4, which is assessing the feasibility of control, which is very similar to assessing the potential impacts, except it's kind of inverse. So feasibility-wise, something would be impossible and you would score it a 0. Something with a 1 would be considered substantial effort. Something with 2 would be considered moderate effort, and something with a 3 would be considered minimal effort. And so for these, we assess 3 things: the delimiting survey, initial control, and monitoring. So for the delimiting survey, we're thinking about things like how much private land is there, how many people do I have to talk to get access, what's the terrain like, what's the number and size of the population, is the species easy to identify by field crew members in the field. And for the initial control, that's where you control at least the great majority, most of the adult individuals in the first round. And you would consider things like, how easy is it to control? Can we use chemical control, or do we have to use mechanical control? How many populations are they? Are they easy to see in the field, or are they concealed by guinea grass? Is the introduction pathway closed, or are you going to get repeated introductions to Kauai over years? Is it a food or medicinal plant or cultural plant? Because that's going to affect how people feel about controlling it on your property. And finally, monitoring. So this is how often and for how long you have to visit to control regeneration. So the things that go into this are like travel time, how long it takes to travel from base to the site, and life history traits. And for life history traits, I have what I think are 3 critical life history traits where oftentimes the data doesn't exist, but it does. But if it does, it really helps plan a control program. So the first one is seed dispersal method. And that's important because it would help determine your delimiting survey buffer. So whether it's wind dispersed or gravity dispersed or something like that. Time until maturity, well, that determines your control site revisitation schedule. Because obviously we want to go back in time to catch it before it starts feeding again, because then it resets our whole timeline to eradication. But we don't want to go back so often that it's no longer, it's taking away resources from other targets that we could allocate those resources to. And the third one is time until seed bank is exhausted or non-viable, which is the one we generally don't ever have data for. And that is important because it basically determines the length of control, the length of your control program for sites that had reproductive individuals on them. Okay, so, and then similar to step 3, you just add up A, B, and C, and that gives you a feasibility score. And then feasibility is scored from 0 to 9, with 0 being this is impossible, to 9, which is high feasibility. That would be your low-hanging fruit. Okay, and that brings us to step 5. So I kind of apologize for the wordiness of the slide, but I put it on there because basically this is where you compare your species during a roundtable prioritization discussion with your committee. So in the end, after you do several species, you'll get this kind of list. And so then to get your final priority score, you add, you account for the WRA score, you add the potential impact score, and you add the feasibility of the control score, and then you get a priority score. And this allows you to rank them from highest to lowest. And so now, theoretically, although there's going to be a lot of gray area, you would have, okay, first priority, second priority, third priority, that sort of thing. And so, and in this table, we also discuss, oh, I should say before I move on, if in the feasibility of control score, if you ever got a 0 in any of the categories, that automatically makes it infeasible. So this is kind of an example of ones we started doing for Kauai. So this is for Angiopteris evecta, mule's foot fern. And it was determined infeasible because of the amount of time and money it would take to do delimiting surveys. But I should say that there are also these 3 other columns here. So it's good just to note, like, what's the current limiting factor? And I kind of just made this font really small because it's not that important, but I made the large one big enough to read. So for Juncus effusus, the current limiting factor is the drive time and hike time to site access, and then sharing data with our partner who's also controlling it. And then there's this column that's the knowledge gaps, contingencies, and action items. And basically this ends up being, an action item that you have to, or a list of action items that you're supposed to do before you keep going. So here we have to do the limiting surveys in the Ho'ono, Pali, Nar, and the first bog along the Alakai Swamp Trail. And then here we have this category, which is the current KISC status recommendation, which would be something like remain as target or is currently an early detection species. And that we're going to reevaluate that after number 1, which is our knowledge gap, is completed. And then it lists the date and the stage. And so when I talk about reporting stage, I'm talking about So when I talk about stage, I'm talking about this. So theoretically, I would do my early detection surveys, and then based on my findings from those surveys, I would go to reporting stage 1, which is where I would complete the report. So I go through steps 1 through 5. And I should also note here that it's really important to do like a peer-reviewed literature search and write that down, because it makes the report more credible. And you can always change it later if you add more data. So I do the report and I assign the score, and then we have a meeting. And from that meeting, based on that report, we decide, okay, is it even worth it to invest our resources in the limiting survey, and should we investigate how we're going to control this and how effective it's going to be? And if so, you do that. And after you do that, then you go to reporting stage 2, where you revisit the report and then you adjust the scores based on what you learned from the delimiting surveys and what you learned from trying to control it. And then we have another meeting where we decide, is this going to become a KISC target that we commit resources to? And if so, then it's stage 3. So that then we revisit the report periodically over time and we adjust scores based on accumulated knowledge. And then, so that allows us to assign a status like, okay, keep as target and look into this. And it actually becomes a really good management tool, because when you sit down and look at this in detail, you start to realize which obstacles are there, and maybe they've always been there and they just haven't been dealt with yet. So then you assign, so that allows you to assign a status like keep as target, retire if it looks like, it's not going down, it's not going to be a feasible eradication target, or hopefully it allows you to assign a status of basically eradicated to our knowledge. All right, so that's basically the whole process. I think there are a few strengths to this process. The first one being that knowledge is going to be our best weapon when going for eradication. It's often going to be like a weird life history trait, or like a list of landowners or something like that that's going to be the chink in the armor that's going to let us eradicate a species. So let's put it all in one place, and then no matter who is picking up the job in a few years or if funding kind of fluctuates, we can always go back to it, and it's always going to be accessible. It is also a comparative ranking design, which I really like, and it allows you to up-rank or down-rank your species as your knowledge about them accumulates And so what I mean by a comparative ranking design is that in some of the literature I looked at, you would assign kind of like a high priority and then moderate priority and low priority, whereas this one doesn't do that. This one is priority number 1, number 2, number 3, number 4. And I like that design because I think here in Hawaii, we're going to end up having a lot of high priority species. And so then you're going to have to figure out how to prioritize things within a high priority category. So this gets rid of that decision. And then very importantly, it keeps track of decisions. I have a lot of people that come up to me and say, like, I told you about this species 5 years ago, and you haven't done anything. Why aren't you controlling it? It's really bad. This is what it does in this area. And so it allows you to put everything in one place and just sort of like hand them reasons, and especially when they see why you've done the things you've done in context to all these other species, they may understand why you deemed it unfeasible. And like, this is especially important. We don't want our community members to think that their taxpayer dollars are going towards organizations that are making bad decisions. So it helps with that. I also like that it's a focus on feasibility, whereas a lot of other models will focus on the invasive impacts. Like in Hawaii, we know that invasive species have a lot of invasive impacts. The problem is figuring out how to eradicate them. So it allows us to evaluate whether, is this species going to be a win or is it going to be a waste? And then if the budget or your resources or staff fluctuates, you can scale your rankings according to your own budget. It's very specific to the organization. And so a list of things that are not necessarily weaknesses, but maybe things to think about is that, yeah, this is a very organization-specific design. Like I said, this has its strengths because it allows you to be very specific about your own resources and tailor them to what's feasible. But I'm not sure how that would scale up. I mean, I haven't really thought about it. Maybe someone would know, but I'm not sure how it would scale up to multiple organizations. And so one of the problems with this is that sometimes we get a plant where it's not only an incipient on the island, it's an incipient statewide. So its only known population will be on Kauai. And so that doesn't ever factor into the ranking situation. The second thing is that multi-land use weeds will score highest, and should that be the case? I mean, so something that is a forestry weed, but not necessarily an agricultural weed, will score very low in the agricultural category. So it's going to be weeds that have impacts to both forestry and agriculture that are going to score the highest. And some people think maybe that should be the case. I think that's where the gray area comes in. A lot of people do think that, if it's impacting human ways of life and native systems, then it should have a higher score. But it does get debated. And then most importantly, this process is only as strong as its upstream processes. So going back to the slide that I showed earlier, we were only talking about this final decision-making process here in this red box about which ones should we prioritize and take on as targets. And there's an entire upstream system of very data-heavy components that could use some work, and I'm very interested in making them better. But yeah, you have to really have all of your data in line in order to do this properly, because if a species is supposed to be in there, but it gets weeded out somewhere during this process by accident, then it's never going to get to the prioritization stage. All right. Okay, so that's all I've got. Thank you very much. If anybody wants to see
Mute off.
references or is interested in doing a system or prioritization planning for themselves, I can give you a big list of references that I've already looked at and downloaded if you're interested, or you could contact me at my email address for any other questions, unless you have a question now.
Kelsey?
Yeah.
This is Adam Williams, Kauai Invasive Botanist. Hi. For anyone else that might still be listening from other islands, I thought some people might find it helpful if you could briefly discuss how you took this whole process and are kind of back applying it to existing targets that KISC already has, because I imagine that may be something that other HISCs, if they were thinking about adopting this, that would be the first thing that they would tackle is, how feasible are their existing targets and how you kind of use some of these same steps to back apply it and how we're going through.
Yeah.
You know what I mean?
Yes, totally. Yeah, that's a good myth. So this list is an example of what KISC is doing. And so, yeah, the first thing we did was look at the targets that we have and put them through the process. And so that's really helpful. I mean, none of the decisions have been finalized yet, but it does provide a really good framework to look at all the things objectively in one spot. And it's amazing how easy it is to balance all of the information you know about a species in one sitting. So it's really useful. And so, for example, using this process, we used to have Angiopteris avecta as a target, and now it looks like, you know, the priority score is infeasible. And so now we're considering retiring this species, or considering maybe a partnership before that, if we can manage that. And same with Rubus seboldii. We're also considering retiring it. We have a few other knowledge holes to fill and stuff like that. So it's really cool in that it helps generate a list of knowledge gaps that you would go through with your own targets and consider before you make any final decisions. Any other questions out there?
Hi, Kelsey. This is James Leary. Can you hear me okay?
I can hear you, yeah.
Yeah, great job. This is really interesting stuff. I appreciate the effort you put into this. On this slide you're showing now, the step 5, you have the potential impact in feasibility as a additive score, but you did mention that if any one of those received a 0, then it would automatically zero out. This is just kind of a basic question, but why not say a multiplier or a product of a multiplication so that the 0 will come out to 0?
Right. That's a good question. I don't know.
We still have a compounding effect of, because they're all equally weighted, right? Potential impact scores are indifferent to feasibility scores.
And so then you wouldn't have that if function, like if 0, then infeasible. It would just go out to 0. I guess I would be really interested to go through and multiply them and then see how that comes out. It seems like I'd have to look at that. That's a good food for thought.
if I might too, the other question I had was, and I don't know if I'll ask it right, maybe I'm being naive or not understanding. On impact, is it possible that you may not get a high impact score on early incipient targets?
Yes.
It would not be apparent as being a high impact plant because it's only known in small populations.
Right. So I mean, it is theoretically based on potential impact. So a lot of the times you're looking towards the literature or basically mining any data that you can to see what it's doing outside of its native range elsewhere in the world. And so oftentimes the HPWF is really helpful in finding those resources. So you would use, even if it's not behaving that way in Kauai yet, if there are resources outside of Kauai, then you would use them. But it does become a problem, you know, if it's not a weed anywhere else. And that does happen. Like Clerodendron macrostegium isn't really, it's a weed here and it's a weed on Oahu, and it doesn't really have too much else. Xyrus, which is this little graminoid that is a terrible invader of our bogs, is a rare plant, and all the literature you find about that elsewhere is all about how to protect it. So, I mean, that does happen, and I'm not sure how to deal with that. Right.
The economists would have a lot of fun with this process, I think, especially on the feasibility scoring.
Yes, and actually, when I looked through the literature, there were a lot of very thorough economic analyses as part of that. A little too complex for me to transfer over in the time frame that I needed some sort of process to get stuff done.
Right.
Hey, Kelsey, this is Springer. I really want to commend you on this. I'm so impressed. One of the things we struggle with is, sort of economics and feasibility. And, if we're considering, say, junkus by itself, it might have a certain feasibility score. But when you sit down for discussions at that roundtable, how did your committee work out, well, how many of these can we do and that they would still be feasible?
Yeah, I don't think we've really gotten that far. basically we have had our suite of targets, and some of our targets are looking really good. And so now we're kind of deciding which ones to take on. But yeah, because there's no economic component where you can actually attach a dollar value, that is sort of a, we haven't really gotten that far to figure out how many we can take on, although there are some. So like our Department of Health permitting, you know, that we can put a dollar sign on. I don't know if Bill wants to comment on that a little bit more.
I think right now it's not economics in dollars, it's economics in time. So we have our repeat schedule, and so we plan out everything that's supposed to be getting addressed, and then you see how many days you have open. And I think that's going to inform how much more we can take on. It's not as empirical as saying, you know, if we spend $1 here, we're going to get $10 back in our investment. That would definitely be helpful.
This is James
Thanks very
here.
much.
Good. Sorry, yeah, Springer, good question. I had a similar question. So I'm assuming that the feasibility score, would this still be based on annual funding cycles then when you talk about time allocation? Is it still on a 12-month cycle, or is there forecasting beyond that?
Yeah, basically when you do the feasibility score, you're kind of assuming that you're going to have the same amount of money in the future that you have now, at least. But if you don't, when you go to revisit it in that stage 3 reporting, you can scale it back. So like driving to a site might be feasible if you have 4 crew members, but it's no longer feasible if you have only 2 crew members because you can't divide their time anymore. So then this would lose feasibility. So you can kind of revisit the reports and adjust the feasibility score as you lose or gain resources. That's the idea anyway.
Hi, Kelsey. This is Chuck on Maui. Excellent job. I just had a few quick questions. I was wondering, I know it's going to be species dependent and depends on the availability of information, but do you have like a time estimate, kind of a range of how long it would take to run a species through this prioritization process? And part 2 question, kind of unrelated. It's more based on the impact and what's known about a species. I may have missed this, but do you have anything to account for taxonomic relatedness for species that might otherwise be unknown or poorly studied, say like Myconias? The entire genus is on the state noxious weed list based on the reputation of Myconia calvescens, and so there's like, you know, estimated to be about 1,000 Myconia species in the neotropics. All of them are, you know, on the noxious weed list now just based on the reputation of this one highly invasive tree. And is there any way to account for that kind of information in there as well?
Right. So the first question was about how long it takes. So the fastest one I ever did was in 4 hours. And it tends to be, there's like an inverse relationship between how long it takes me and how much data is in the WRA. So if the WRA has got lots of question answers and lots of resources, then it tends to take me less time because I have a good reference, and then I might just skim to see if there's been anything reported in the literature since then. So the fastest one I've ever done was in 4 hours, which I think was for this ivy gourd Coccinia grandis. And then the longest one I ever did was 2 days for Ficus religiosa. And it just depended on how long or how much information is known about that species. You know, it's almost like the more that's known, it kind of makes it harder because you have to sift through more stuff. You know, it's almost like there's a parabola effect. If there's nothing known, then you really have to search. If there's a moderate amount known, then it's kind of less time. And then if there's a lot of information, then you have to sift through that. And there's just so much known about ficus and, you know, their pollination syndromes and stuff like that. So timing is anywhere between 4 hours and 2 days. and we'll see what I'm getting a little faster. We'll see how it goes in the future. And then as far as interrelated species, that's a really great, closely related species. That's a really great question. And I tend not to account for them. I tend to try to evaluate them based on the species only. That's the first filter, but I have mentioned it. So like for this Clerodendron macrospegium, I think I mentioned the suckering habit of Clerodendron quadriculare, which is really well known. It's like a common landscaping plant that suckers readily because we just didn't know much about, this plant elsewhere in the world. So I do tend to use it, but yeah, you're right. There's not like really defined limits. It's definitely a gray area of how I consider it. But if you have any suggestions, I'd love to hear them.
There's feasibility to your step 5. That was a joke.
What's that?
I was interrupting, but I was just making a joke. So it sounds like there's a feasibility to your prioritization process.
Right. That's true. Any questions out there?
No. Okay. Well, yeah, this is JC. I guess kind of the host for this brown bag. Just wanted to thank you again, Kelsey, for your wonderful presentation. Lots of really good information that you have put out there. And I look forward to just getting more refined and you getting faster in this, really driving some good information gathering in the future.